Oh, excellent. Thank you.
Somebody, yeah.
Thank you, Ellen. So there's 5 clubs that generally show up. Anyone here from Homebrew Robotics? No camp. Okay, Riverside, the Robotics Society of Southern California. That's a whole bunch of you guys. How about the Seattle Robotics Society? Anyway, okay. Of course, then there's Riverside Robotics Society, at least one. And Tech Room, a couple there. Okay, beautiful. Well, from past meetings, notice that there've been long and short presentations. So I'm going to keep a cue on a wonderful piece of paper using old school. So if you have a show and tell, please put it in the chat and tell me if it's a long or a short. Long being about 15 minutes, short being about 5 minutes. And first come, first serve. I want to, as they appear in the chat, I will write them down and we will go from there. Hope to see lots of good stuff.
I'm busy just catching up with the chat at this.
Wait, I put it, I sent that to, I sent a message to Catherine by mistake. Hold on.
She'll say hi. She's not shy.
Hello, Catherine.
You're muted, Catherine. I can't hear you, but yeah.
Everyone.
Hey, guys.
On this medium. Can I do a medium?
We'll call it a long.
Okay, call it a long. This way, if it's
Did
shorter,
we
we don't
define
care.
what long and short are? We didn't define the protocols, did we?
A long, 15 minutes-ish. It can be shorter, of course, and short, 5 minutes-ish. Okay, and we got
Gemini so far.
okay, well, we got 2 longs going there. I may announce that numerous times during as people come and go.
I think all of us have something to show every day. It's just a matter of whether they want to show it or not.
Yeah, everybody's got something usually going on.
Whoops.
Sometimes it's good to mix it up, you know, software, mechanical engineering, electrical. You know, there's so many different areas that anybody can present something on.
Absolutely.
Doesn't always have to be a running robot.
It's going to take the leftover time.
Is that Britt said that? Yeah, that one was
Yeah.
interesting.
Running robots. I'd be lucky if mine just fall over while they're walking or stumbling.
Hello, this is Jim Ubersetzig. I have a very simple question. As a member of the RSSC, I'm not familiar with the Tech Room organization. Can anybody tell me a little bit about that Tech Room organization?
Catherine, you're really good at that. Why don't you go for it?
So the Tech Room is a robotics club based out of San Bernardino County. And we've been there for approximately 8 years. And we're a small club, but we focus mostly on presentations.
I see.
Mm-hmm.
One small thing, a lot of the members from the Tech Room were also members of Riverside Robotics and the RSSC.
Okay.
Right.
A lot of
And
overlapping members.
We welcome everyone.
Is there a contrast or is a small difference perhaps between what's going on at the Riverside Robotics and what was going on, or what is when you still had face-to-face meetings at the tech room? Or are they essentially identical?
No, I can attempt to answer that. I don't think, having been at both, I don't think they were identical. If anything, Thomas's were more organized. And
Sometimes.
and we generally, for example, Phil would do some videos or some business, robotics business, you know, keeping up. We had one thread going on with what's going on with the industry. We definitely had a building thread, you know, bring your tools, bring your stuff, bring your bots. We had project building classes similar to in conception, I suppose, to what you're familiar with Thomas's. And we had some different ones. We had a soldering class, which turned out to be interesting. We had people of all flavors, from rank beginners to advanced people in this and that. So, but I think if I were to sum it in a couple of words, it was more freewheeling sometimes. You know, the meeting was guided by who showed up.
Now, when you say the meeting was guided by who showed up, or you're talking about tech room?
Yes.
Okay. I see. Well, thank you.
Yeah. That was the freewheeling part.
Yeah, I understand.
And Jim, you're always welcome.
Oh,
Sorry.
okay.
I could give my experience of the Riverside one, where I would say that was pretty much the same, outside of there were different people there and people brought their stuff in person so you could see it while people are talking, and there was food. But outside of that, it was kind of the same. I guess the only difference was you would notice when the next class would be. And people might linger, but that was it.
Okay.
And you've never been to the Riverside Club? And have you ever been to the Riverside Club?
Yes, but that was quite a few years ago.
Oh, I see.
Between then and now, I thought there were a couple of changes in management at Riverside Robotics.
Well, we've had different leaders over the years. Alan was a leader for a couple of years. Thank you, Alan. And we had another gentleman who's no longer with us. Oh, I mean, he left the club. Who was president for a couple of years. I kept recommending that Forrest become president, but he never took me up on that. Anyway.
Who's president of Riverside Robotics currently?
There's
You all. Okay.
Remember, a lot of us are members of all three clubs. So there's a lot of overlap here.
Well, that's good.
Yeah.
Sure. We just can't get, we're just robot nuts, you know? We can't get enough. Some of us joined the Homebrew Robotics Club, and God, every day is a robot meeting practically.
Yeah, they're really prolific. They have
2 times a week sometimes.
Ross meeting every week, and then the 2 Wednesdays a month with the anything like robot development, and then the main meeting, which is coming up this next Wednesday. But that I finally formally joined that the Homebrew. They only ask for $10 as well, but then you can have you have access to the full features, including the builders page, where you can submit. I haven't done it yet, but you can submit some photos and a bio, and your robot, and they'll put it up on the builders page. So they want to build that up. They're kind of, it's not enough yet to really that they have a goal of getting more people on there. So if anybody wants to join that club and get your builder page up, that's something unique from that we don't have in the other clubs, I don't think.
Yeah, they have about 60 people on it. Show up sometimes, 40 to 60 people. They're a much bigger club than us. And they
Yeah.
have a lot of high-end speakers as well.
Yeah, they're very, I would call that group is advanced. There's a lot of advanced developers, and you can learn a lot from them and what they're doing. It's inspirational. Even if it's kind of quick when they show you something, you'll have to dig in or email the person. But that big showcase they had last month, when it was with 25 different roboticists presenting, it was quite a lot of really good work. So I highly recommend them.
Well, Thomas, where'd you go? There he is. You ready to rock and roll?
Sure.
You're first on the list.
I may have to add one other announcement. In May is it? Japan is having their Maker Faire. And if you want to present from anywhere in the world, just put it on their Twitter between certain hours of that day, and they will broadcast you throughout the fair, I suppose. So I posted that link a couple of days ago. I'm going to participate. Luckily, it's not like 2 or 3 in the morning. It's like 11 or midnight or something. You got to post your thing, and it has to be between this hour and that hour. It's a very narrow window. So I don't know. I just want Japan to know that we exist here in America, that we're interested in robots as well. Well, this is the Tokyo one, so it's probably one of the bigger ones, I'm guessing. Anyway, yeah, I have something to show. I want to show off some of Simone, my fembot in the background there. I'm not going to show her moving because that's, again, she's got a lot of it apart right now. It's not working properly. But I did want to show some of the software I'm working on. Probably go pretty quick. Let's share my screen. Is screen sharing enabled, Phil?
You have to ask Alan for screen sharing.
Alan?
Yeah, you should be able to.
Okay.
Don't see it yet.
I'm working.
Okay. I heard a click.
Yeah. I just realized a lot of people have small screens, so I'm going to have to swap some screens. I got my 32-inch screen on top. I'm going to have to switch it. Otherwise, you won't be able to see it.
Does Zoom have the facility to share a window in addition to sharing a full screen? I thought I saw that one time, but I forgot where it was.
Oh yeah, you can share an individual window, or you can share your entire desktop.
Okay.
Okay, here we go. Screen 1, screen 2. There.
All right. We're in. You see it.
Okay, this is what used to be known as the Easy Robot software. Now they're calling it ARC, A-R-C. This is for lack of a better word, a framework. I've been talking about this for many years. I know a lot of you have seen this, so I'm just gonna give you the highlights and then show you exactly what I'm working on currently. I've divided this up into 8 different pages of skills. They're calling each one of these little boxes a skill. Every box does something different. Well, these do something similar. These are motor controls. And this is the camera. And with the camera, I get all sorts of fun stuff. I get face tracking, color tracking, and so forth. One of the biggest highlights that I like is over here. Now you set these up yourself. These are all skills. This is all my 3 sensor skills for the robot: her left shoulder, her right shoulder, and her tummy. If you touch her tummy, she giggles and says, "Stop that." This is the highlight of it, I think. We have a whole bunch of AI coming from the cloud. We have Microsoft services. We have cognitive face here that can identify a face. And also it tells you who you are. If you store your face in their database, it can recognize you anywhere in the world. Cognitive emotion, it looks at you and decides how you're feeling just based on your facial expression. And there's also a verbal part of that. When you're talking, cognitive sentiment analyzes the actual words that are spoken for emotional content. Over here at Site Cloud, it looks at your camera and describes what it sees. This is equivalent to some other programs that you've seen that identify the objects in the camera. Cognitive vision, again, similar to Site Cloud. So you have two. And you also have a third vision thing is DarkNet YOLO, which is similar to TensorFlow. It identifies up to 80 objects in the camera, probably at about an 80 to 90%, not very accurate, as a lot of us have found out. So these are a lot of things that people are bringing into their robot software for interacting with the world. And the best thing about these is you bring them in and then with a few lines of code, you can integrate it into your robot. The simplicity of it all is unbelievable because I spent a good 2 or 3 months getting DarkNet to run on my own PC. I mean, it was ridiculously hard how many corrections and updates and further corrections I needed to make this thing go. Unbelievable. And here, to bring it in here, it was about 2 clicks. And I brought it in, and now I can call it through a script and have it work instantly and report back what it's seeing. And that's about it for that part. Now, lately, this is what I've been working on here is the AIML BOT, the AML bot. This is AIML software based on the chatbot named Alice, one of the original chatbots. I've been writing a whole lot of this AIML code, and I've come up with a few shortcuts. And Jim might appreciate this more than anybody since he's been trying it out. Now, one of the problems with AIML is it's text cumbersome. I'll call it that. It takes a lot of text to because it's like HTML. You have so many, you have a start tag and an end tag and tags buried in tags and tags buried in other tags. So here I made it kind of simple. I put the boilerplate stuff to the side, and in the middle, I put it in the spreadsheet, and then you have the input column and the output column. And over here, you have multiple input columns in case you want to say, change the input. So in this instance, it's the input would be, are you admired? And the output would be, I'm sure someone admires me. Are you amused? A little, not really, and on and on. Some of these are more important than others, and some will later on have an impact on the other responses. The whole idea of this is to create an artificial personality. A personality. Now, is it a trick? Yes and no. It is a trick to an extent, but it also has, I'm also storing variables on what occurs during the conversation and I am basing this on Leaf. Everybody who's familiar with the Leaf robot knows that Leaf could be bored, and he could be very bored, and so could my robot, among other things. I'm just building upon that because I like that part of it very much. Alan suggests we make this, somewhat of a programmed effort, and we put biases in. If you tell the robot, I hate you, well, its like for you is going to go down, and then that's going to be a number, and its total disposition is going to be reduced by 10 to 20 points. And if you tell the robot it's ugly, it goes down another 10 or 20 points. And as it goes down, the responses will change or up as the case may be. Some of these things is names. It didn't know names, so I had to input a whole bunch of names that it could recognize. Input would be I am, and the output is my name is blah, blah, blah. And this is a redirection to one that SRAI is a redirection, a pointer. These here are some of the commands that I would send it to it, like open your left eye. This is for my testing purposes. Then I would turn the servo on and put it at a certain position. These are all the commands I have for the robot. Another thing is I wanted to figure out all the phrases that you could ask, that people would want to ask a robot. Because this thing, you know, I'll bring it to maker events and meetings and such like that. And this is the next one I'm working with is can you and do you? Can you argue? And I haven't gotten that far. Can you do math? Can you dream? These are things that people would want to ask robots. Yes, the robot can read, by the way. That's another skill that I've imported. This is one that hasn't even been started. Do you like? I also have a dictionary I'm working on. If anybody needs a common dictionary for basic words for a robot, let me know. I have it. I'm actually putting it into place. I was working on it last night. I have it up to, what is it, about 2,000 basic words. I think it's 2,000. I don't know, it's a lot. I keep adding to it and adding to it. Let's see. Anyway, so.
Now, Thomas,
Yeah.
as the timer, I'm going to interject. I'll define a medium as 10 minutes because it's halfway between 5 and 15.
Okay. We're going for a long then.
Okay.
Well, as I'm changing this and modifying it, it's getting more and more responsive, and it's giving better and better reply. And eventually, since it's going that way, I can say that it's going to be able to answer almost any question, and almost any question is going to sound like it was a human responding, and not like a machine. And that's the high goal. Is it going to be reached? Well, yeah. This year, no. It can be in 5 or 10 years. One of the advantages I have is I can code on the back end variables and special circumstances and edge cases where you couldn't do that in AIML by itself, not easily anyway. I can also bring in the visual from what it sees and audio from what it hears. So I've got a lot of advantages over just plain AIML. AIML, of course, is the computer language for chatbots. I might as well give a demo since I'm here. Now this picks up anybody's sound. So if you would please mute your microphones, and we'll try saying hello to Simone. Good morning. I'm fine. How are you? Okay, it's call me hun because I haven't introduced myself. I have a new script that I'm working on that looks for the face. If it recognizes you, it'll start calling you that name. Another thing it'll do is like your hot word on Siri or Alexa. No, not you. My Alexa turns on. Not you. The face works then, your face, when it identifies your face, 2 eyes, it then works as a word to start listening. My name is Thomas. What are you doing? Are you a robot? A good guess. Haha. All right, that's about the end of the demo. Any questions before I end off?
Hey, Thomas, you said you're tying in more than AIML, but from other sensors, et cetera. But is AIML sort of the driving code, or is there a more central driver that takes in, that's above AML and the other sensors that ties things together? For instance, if you get a sensor bringing in information and you want to change a variable, are you using the scripting language or something else?
Yeah, there's a scripting language behind it. A lot of it's independent, and I'm just like Ross, I'm passing data between different packages. If we could call each one of these a package, then yes, I'd be passing data between them. It is loosely joined together. All, for love it or hate it, all variables are global in this system. So every package, every skill, as they call it here, can use data from any other skill. For a central processing unit or a central process that's running everything, no, it's pretty much distributed. Will there be? If I see a need to, I'll write one. But right now, I don't have a need to.
Thomas,
Another
can I follow
question?
on? Oops, sorry.
Really?
Yeah, so Thomas, quick question regarding AIML. So I have a little bit of experience with AIML, and last time I used it, the problem that I was having was it was difficult, or maybe, I don't know, impossible to get AIML to learn new facts. For example, if I wanted to tell my robot that a dog is a type of animal, or a dog is a mammal, I had problems with AIML acquiring new facts. Is that something that you've seen, or maybe you've solved that problem, or maybe it's not even a problem for you? I don't know, but do you have any thoughts on that?
Yes, I do. Out of the box, it's supposed to be able to add new data. That's when you use it on like pandorabots.com. I don't know if you've ever used it through them.
Yes.
Yes, it's supposed to. I've never got it to work right. With this version of AIML on top of the ARC, or rather ARC software, you can save off data, you can write files, you can read files. I haven't done it yet, but it's in my list of things to do. And the answer is yes, definitely you can do it with this system.
Okay, cool.
Anybody else? All right, back to you, Phil. Or,
Okay, you are punctual as hell there, Thomas. If you wouldn't mind unsharing your screen so Jim could hop in. He's next.
All right. Yeah. Today I wanted to just show a little bit of mechanical engineering that I did to create a tray for my big orange robot, because I want a cargo tray essentially. And here I'll show you the what it looks like. Yeah. So the robot didn't have much space on it. Didn't have any space to carry anything. And since I'm in this contest, the Open CV AI contest that Brian Erickson and a few of us are in, or the social distancers group, one of our goals is to be able to deliver something from one person to another in the house. So yeah, I have a drink holder here, a little depression. It fits it's for a soda can. And so, and it's bolted on, and it actually, the robot has,
my name is Orange.
oh, sorry, it's starting up.
Pleased to be at your service.
The robot has like a cylindrical layers. And so what I did was I 3D printed this and sandwiched a layer above and below the arc of the front of the robot, which sticks out about 1/3 of the way. And so you can see, I can push on this. You could put like a 2-pound, 3-pound weight on this, and it'll move the robot before it breaks or anything. So, and I want to show you a little bit about how I did that. In Fusion 360, which I'm still kind of, I'm not a real expert. I'm still fairly new to it. Let's see. Can you see the, you should be able to see this Fusion 360 now.
Yeah.
Yes.
So this is what it looks like with all the pieces. So part of the challenge here was I decided I wanted to do something larger than my printer could handle in one piece. So it had to be divided up into multiple pieces that could be printed and then glued together. And so if you hide some of these different bodies here, you'll see that, well, you can kind of see that each of these is a different piece. And that was a later step, obviously, was to break it into pieces. But so for instance, here's above, lower left, above, lower right is over there, then above, upper left, and then above, lower right, and then below. When I say below, that is actually below the top layer of the robot. So that's why these are separated here. It's a 3 millimeter. Well, I just broke these out because there are 2 different pieces that are going to get glued together. And then there's a guard on top. Now, so I made a little serrated edge here for gluing. And then what's also interesting is to glue these different pieces, I made a large overlapping area on several of them. Like, for instance, below right and below left, they overlap by quite a lot. And then that's where the glue goes. So, and I'll show you a little bit about how I started. It's all with the sketches. So if we go to like the first sketch I did, it was this one here. And you'll see that it's mainly just circles, lines and circles, and measure and constraints of measurements, and then the screw holes and all that, and then extrusions to create the different pieces. And what's kind of cool is you can, I'll exit this finished sketch. And there are other sketches that, let's show you. Different sketches were done different things. Like this sketch was simply a way to cut. Some of these were to cut the object into different pieces. Like this is these are different cuts through the lengthwise dimension. And let me exit that. Oops. Oh, I turned off sketches. So so that's how that works. I mean, there's a lot of detail to, but you can create different sketches and then do different extrusions from those sketches, and you end up with the bodies. And then I broke up the bodies into different pieces for printing, and then printed them all and glued them all. So it's kind of it's a neat process. And oh, one thing that I didn't say here is that's sort of different is I went into the drawing in order to make sure things would fit. I printed a piece of paper with some of with this sort of the outline of these objects, at least with the upper and lower level, to see that the screw holes lined up and that that things fit properly. So that was in the drawing area, where like you can go and into the drawing mode, and you can let's see if it's going to come up here. There it is. So I printed a piece of paper with this on it so that I could actually go and see if it worked, kind of fit properly before I 3D printed. And I made some adjustments, and then you know, because it was the wrong, something was slightly off. So that really helped prevent wasted time. And yeah, so that's that part. Anybody have any questions about this?
Yeah, I got one. I'm curious how many hours of work, let's say, on the design you think you have in that.
Yeah, I mean, it wasn't too bad, even though it's probably a little longer for me because I'm, you know, I'm not that proficient with this software, but it took several hours to do that. I mean, in a few hours, multiple sessions, I'll say, and then, you know, making some mistakes and backtracking, but, you know, nothing huge. Just there was, most of this was not too difficult as far as advanced features. It's using kind of fairly basic features of the software. You know, the solid extrusions and fillets, I guess, and drilling holes. It's not too complicated. A lot of the longer part was kind of dividing it up to get it to print properly. That takes time. And oh, I wanted to show you the well, one of the best features of the software is the parametric history, and so you can rewind it and then play it forward and see as things developed. I guess it doesn't show. Yeah, there it goes. Well,
But you're saying it kind of has infinite undos back to the beginning. It keeps everything.
yeah. Well, parametric. It's what's really cool about this is you do an operation, and you can even change the order of these, but and then that operation can be depended on by future operations. And so if you want to change a dimension, you can go back to, for instance, an early sketch and then change the dimension, and it will, like, you could change the dimension of something here, and it will propagate all the way through to the end, unless there's some sort of conflict or something, but that's what's kind of cool about it. So it will, you can essentially rewind, edit something earlier, and then close it out, and then it will apply that. So it should, for instance, I'd go back to something like this. My whole, I could make this hole deeper and wider, and then hit OK. And now it goes forward to the end, and everything, anything that depended on it would be, applied. So
Have you considered doing a workshop on Autodesk Fusion? You're really great at this. This is pretty cool.
no, thank you. I defer to the other, people like Alan have given multiple demonstrations and workshops, but I eventually, as a beginner, maybe I have a different kind of insight into it, or into how a beginner thinks.
Jim,
But
this is Buzz. Nice job. Very intriguing design, and I think you've done a marvelous job on this. I have two questions. One is, in the actual 3D printing of the material, it's my understanding, after listening to everybody talking about 3D printing, that there could be some tolerance problems after each piece is printed relative to the edges and size of things to be able to fit together. If you could comment on that, I'd appreciate it. But even more importantly, the second question is, do you have like a guide wheel underneath the robot that would help support the body of the robot from a center of gravity standpoint when you actually put things on the tray? As you demonstrated earlier, as you push on the tray, the robot tends to tilt forward. So how do you deal with essentially keeping things stable as you put a load on the tray, in terms of supporting that from the center of gravity standpoint of the robot itself? And it would seem like a guide wheel in the front might be something that would help.
yeah, that's a good question. I haven't really done a lot with that, other than I've tested it with a 3-pound weight, and it doesn't tilt too badly. And so I was thinking of doing a balance, or if there is a weight issue, I would add add a kind of a weight, add some center of gravity adjustment. But
I guess you could also have a counterweight in the back too, of some sort, a little lead weight or something that you hang off the back of it, that would kind of help compensate if necessary.
yeah, that's see, if I put this is 3 pounds, even at the if I go at the edge, that's not good. But if I put the 3 pounds in the middle, it doesn't deflect. Can you see that?
Yeah, yeah.
This isn't meant. This is meant to carry some small household items, like a drink, some medicine, a book maybe. But if 3 pounds is, I don't know how much more I'd go, but yeah, your idea of a wheel, some sort of thing in the front may be a good idea, like a caster.
Yes. Yeah, that's what I was thinking of, like a caster wheel underneath that particular, toward the edge of the underside of the robot, so that it would tend to stabilize the thing, wouldn't rock back and forth quite as much as that.
Yeah, that sounds like a good idea, and I appreciate any input about that. Yeah, the battery is towards the back, so it was kind of back heavy anyway, but looks like, yes, I forgot to set my timer.
That's 15 minutes, but you are into questions, so.
This is Jim Ubersetsig. I have a simple question. What sort or what type of glue did you use to assemble these various parts of the tray together.
Oh, yes, that's, so I got advice online from some forums, and I used, for the larger, those larger faces, I used a 5-minute epoxy, a particular brand of, I can't remember right now. I emailed it to, emailed it to Alan. And then for the smaller pieces, like that top of the little tray guard, I just used essentially super glue, CN, cyanoacrylic. And I just got these off of Amazon. Well, here I'll show you. Let's
Oh,
see.
Jim, real briefly, could you address the issue of my first question of the
Oh
tolerance?
yeah, I didn't. I'm sorry. Yeah. So well, let me just say it's Bob Smith Industries. 5-minute quick cure epoxy, and then I like the Zappa Gap for the super glue, and I like the brush actually, because the brush lets you, as opposed to the eyedropper, because it's a bit easier to glue some small piece with a little brush. Anyway.
And what sort of plastic did you?
Oh, this is PLA. This is all PLA. Yeah.
Okay. Thank you.
And well, I'm sorry. Phil, the first question, or the question, the first question you had was
about how you dealt with from the 3D printing. It's my understanding that there's like temperature expansions or something along the edges or whatever, that type of thing.
Yeah, I mean, it seemed to work pretty well. I make an effort to calibrate my printer pretty well, and I just calibrated it. And I do measure I use a caliper and measure the filament going in, and put the average of several measurements into the settings essentially, so that the size is pretty true. And I use all the same, it was the same roll of filament for the whole thing, same exact temperatures used, and done within the same few days. So I try to keep all those, I mean, I don't know if that really matters, but keeping all that the same, and calibrating things. And, I have a calibration cube. I mean, Alan originally gave me one. You print a calibration cube with a single, it's called a single shell, and which is just a spiral. They have a spiral mode on the spiral vase mode, and it just the printer will create a single extrusion width cube, and then then you measure it with the calipers, and that's a way of.
So ultimately, then all the pieces interlock together without any real problem, especially the side guard, or where you had the little interlocking part in the center there. So that went together without any problem then, as far as dimensions went.
Not too bad. Now, one of the things I tried to do, based on I think Chris Albertson's advice, was to get these pieces to interlock mechanically to some degree before gluing, so that the lineup would be easy. So with that guard, I didn't do it quite right, but I put little pegs and holes, so that when, before gluing, I could actually snap it together in certain ways. And same with the larger pieces. They had like a little square peg and a hole, and then they would mate easier before gluing. So it's to line it up. But as far as the lining up and or the different pieces being working or being correctly sized for each other, it seemed to work. I mean, I have a nice printer. It's the Prusa original Prusa i3 MK 2.5S. It's an expensive printer, like $900 printer really. But it's paid for itself because of it's very accurate and all that. So that, you know, your luck may vary, of course, but
Thank, thank you again for all of that, Jim. You did a really nice job on that, and looks good.
yeah, thank you. Thank you. Yeah, it took me, you know, it took a week of my effort, or, you know, my spare time effort to, but I figured this is a nice diversion into the mechanical aspects, which I need, you know, I need development on. You know, I need developed skills in that area. So, well, thank you. That's it.
Printing? Was it a week for printing or a week for designing the?
No, I mean like the whole sort of from initial design to getting the print done a little over a week before it was completely installed, you know, with the screws and everything. But, you know, you know, I had to spend, I tend to like to focus on one thing. I seem to do better, even though there's many other distractions, like, oh, there's the software and there's the electronics and but, you know, if I set my mind, if I really want to get this one thing done, I just have to focus on it. And so it's a sacrifice I have to make, but that's how it seems to work. So a little over a week of your spare time. And
Do you have an arm? Do you have an arm yet that will place your soda on the tray?
that's yeah, that's an added benefit I want. This eventually would be nice to be able to do, except the arm has to have a place. So I guess the arm will have to fit on the other side of the tray or something.
Yeah, on top, and it'll just reach in, lift, and then put it on the tray. That would be cool.
Yeah, that'd be fine. I'd like to have an arm. Dr. Bruce is playing around with an arm for his, you know, robot, his big, I guess he renamed it. It's no, but it's no longer called Hoot. But yeah, an arm. I'd like to work on an arm at some point. It's a little ways off, but anyway, thank you.
Yep. That should probably be the last question. Thanks. Yeah, that's great.
Thank you, Jim. Thank you.
Good job, Jim.
Excellent.
Thank you.
Now, Britt, you are next in line, but you said you wanted to wait to the end. What do you want to do?
Oh, I actually wanted to ask Jim a question about his project before I start on mine.
Well, let's let her use her time for that. Yeah, because it's tough to predict how much time will be left over.
Yeah. Well, it's a quick question though. Like, oh, since you're beginning with this, what got you to have that like inspiration, that trigger to get you to think, this is something I should 3D print rather than just buy it or do something else?
Yeah, well, you know, when you have a lot of hammers and nails, you tend to use the hammer and nail things. But you know, I have this. You know, I'm not. You know, this print of this robot from DF Robot, this HCR thing made out of aluminum, or I don't even know if it's aluminum. I assume there's like, it's an old product and there's not much, you know, support for add-ons. So you kind of, that you could buy. And other than that, it would mean working with other materials like metal and or some, you know, and being able to cut metal. And I have no experience in that. Whereas I tend to take the least path of resistance when it comes to robotics based on time and effort. So I'm like, I have some experience developing with Fusion 360. I have a 3D printer. At first I thought, oh, let's make it fit the 3D printer in one piece. Or then I'm like, nah, that's kind of, you know, it's time to take the challenge of making something bigger with the printer that is what I want, rather than you know, sort of settling for. So the 3D print was because I'm just at the level where I think, oh, I can probably do this myself, and it's probably quicker than getting someone else to, or getting a piece of metal made, you know, or trying to cut a piece of plastic. So and it's a fun to do the challenge. So yeah, that's how it, does that answer your question?
Sure, yeah, I would say it does. So do I just like go on to mine?
Absolutely. Just let her rock.
Cool. I was trying to set it up while Jim was answering my question, just so I can not use too much time. So I'll share the screen. I didn't finish, but that's okay. I did what I could do. Um, so I'm kind of just showing, like, because I invest in stocks, you know, because I help out with the robotics. I can't really build my own where I live because I don't have enough space and stuff. So and ideas, and so I just help out with other people's, or I fund other robotic ventures. So this is one of the first ones, Park Aerospace, and what they do. It's kind of hard to see, of course, but they do UAVs. Wait, I know this is a military one, but they do and this is drones, you know. Um, so it's like I didn't even know I had a drone stock. I was like, I want to invest in drones, and then turns out I already am investing in drones. So that was really funny. Um, I think let me try to pick. I was trying to type in drones. Okay. Let's see. I don't exactly know where it is. But I do know it does drones. That's all I know about that. Let's see what that one says. I actually haven't looked. I just figured it out today. See, see the UAVs is commonly referred to as drones. I think everyone kind of knows what a UAV looks like, but you know, we can always just look at what a UAV looks like, but it's just, you know, unmanned UAV. Yeah. It always does that when it's slow. Um yeah. You know, they kind of look like drones, regular drones, drones. So stuff like that. And yeah, obviously this one uses it for the military, but I feel like there are good and bad uses for drones. I always look at like the good uses. Some of them are with agriculture, so that they replace animals like bees, or it's because farms are so big these days. Um, so it's stuff like that. I'm very selective as to what I pick. There are of course the drone stocks that will do agriculture or other stuff, but I picked this one. Then there's this one. I got very, very lucky because I've been looking for this one for years. And so this is a shell company, and of course shell companies are going to be the financial. It's like sometimes it takes to get an idea through, you need money and the idea. So, but sometimes you don't have both. So the shell company's the money side, and then there's a business, that's the idea side, and then those two merge together to be something legitimate, to have something work. So this one is the shell, the money side for um, this one called Arrow Farms, and this is the largest vertical farm in the world. Um, and so they, of course, some vertical farms will use bees and stuff, but I like how this one doesn't. So they said it's completely automated. Um, so let me pull up what this one does. And what they do is because it's a vertical farm, they get to really control as to what is like how the crops are grown. And what they do is they collect data on each of the crops. And they sell that data, I bet. I mean, they don't tell you, but I bet they sell the because they collect a lot of data and they get to determine what wavelength and which wavelength each plant needs. And they control lighting, everything, you know. I mean, this one, people pick the crop. I think they're maintaining it because they said that they have it where it's automated for that. But some of them you'll see, like, I showed with the homebrew, like, some of them are, like, really automated. With, like, cutting it up and everything. Like, Plenty Egg, that one is really, that way. But yeah, it's like it takes something like that. And of course that's automated too, but obviously it's going to be a lot more work. But you can see they were on the computer and they do, and you can see all of those. That was like all the water automated, the watering, it goes a lot quicker. I mean, I grew outside versus inside, and it goes from like three weeks to get it to sprout to like the next day. Let's look at the technology. Yeah, so that's what it kind of looks like. They use this reusable cloth, and you can see it's aeroponic, not hydroponic, so it uses even less water. And LED lighting, so it's automatic lighting. With my hydroponic garden, it was like the lights turned on and off on their own. The water, it watered on its own. So it's a lot more automated than like a regular farm or like a garden. Like farms are of course automated. You have these days where it's like the tablet and the tractor runs itself, which looks so creepy because no one's driving it. But yeah, they will check it on their tablet. Yeah, smart LEDs and aeroponics, and then you could see they do on they check they monitor it kind of like a water treatment system, but it's a farm. Yeah, and then it just does that. And I guess they don't really have pests, because they mitigate it. Yeah. Um, I'll go to the next tab. Yeah, this one is a prosthetics company because I really feel like, you know, prosthetics are pretty robotic with, you know, there's the exoskeletons and then, you know, like parts that are, you know, instead of like biological joints, these are like, you know, robotic joints, you know, gears and everything. Um, it's a cool company because they really solve a lot of health issues, but they have the prosthetics. I'm not really sure how much. Oh yeah, here it is. I don't know how much how robotic some of these are. Let's see what they look like. So it's like that, you know, basic prosthetic stuff. Um, but I mean, I'll show you after. Um, yeah, but it's these are prosthetics. But if you look at, well, um, I don't know, it would be hard to look up. But there's like there's these prosthetics where it's like they have like hydraulics and computer parts on it where it helps with like knee bending because sometimes knees they kind of don't automatically bend as much and stuff. So it's like, I don't know, I try to look at stuff that is kind of related to robotics to kind of see that robotic next step, because with robotics it's never like going from reality to robotics. There's always these intermediary steps. So this is like kind of that intermediary between like a person in a version. um so this is like the prosthetic part, the non-biological parts and everything. I was trying to think which other
Yeah.
ones I
Just letting you know you're at 10 minutes.
have. Okay, should I
No,
continue?
carry on. Just, yeah, just so you know.
I have another stock. Oh wait, I just bought. What is that one I bought today? Oh yeah, I remember. I put it into the Google group. Okay, so this one's a cool one. The AST Space Mobile. So like normally you have cell phone towers, but that's not, I don't know. It's a little robotic, but not really. So what is robotic is this one, because this does satellites in space for the connectivity. And with the 5G, there's a lot of health issues if you have these towers near you. So I bet what they can do is, I mean, once they get this going, this is like Starlink, but once they get this going, I bet if someone needs connectivity, they might take a satellite and bring it to where the person needs it. And that's the beauty of like these free roaming satellites. I wonder if it shows here. Yeah, see key satellite modules like Starlink. What was I going to say on this? Oh yeah, there is this other stock I kind of own, but I didn't really like it because they were it was a shell company too that did other ones. But this one is of course a shell company, but they do like space infrastructure where they actually shuffle around the satellites. Oh no, sorry. That's a shell company for the company called it's so hard to keep up with these. Momentous. And these are the people that send stuff into space. So they're like, this is like the first space infrastructure company on the stock market. And what it does is it's these robots that will shuffle around the space modules like that AST mobile. Yeah, like okay, so first space infrastructure company. See, that's like a shuttle thing where it says whether you're delivering your satellite or cargo to its final destination orbit. So like, the orbits on Earth, low Earth orbit and LEOs and stuff. That's what it does. It'll put it to where it needs to go. So it's like, I don't know, these companies, it's like they're semi robotic, but they really do relate heavily to the other robotic stocks. So you can see like how it works and all that. But this one is like pretty robotic there. And then okay, um and so yeah, I own I did like Virgin Galactic because they also send, I mean, this one is a lot less robotic because they are it's kind of like an airplane but in space. But what it did lead to was this other stock, which is another they call them SPACs when they are like these shell companies taken up by the real business idea. And this one I think is Rocket Labs. And Rocket Labs, that's the one that will send out rockets into space. So I kind of buy the intermediary ones because sometimes I just don't understand robotics enough because it's too complicated. And so I buy these intermediary stocks to help me understand the robotic side and the reality side. This is the one. So they shot, put rockets into space, satellites, that they send out, and it's kind of like interesting stuff. So, yeah. And then I guess this last one where, this one, I was talking to Catherine about, liked it, and I didn't know until I spoke about it. So this one, oh, it's you could see this one. It's autonomous, manned and unmanned, electrical, vertical takeoff and landing aerial vehicles. So these are like sky taxis. Like all these things are just so cool, you know. Also, they look very drone-like. I think they are kind of oversized drones, kind of inspired by it. But it's like, it's kind of cool because then instead of having like roads and everything, which take up a lot of space and bother wildlife and stuff, it's like maybe in the future there'll be taller skyscrapers, maybe even space elevators. And this will be pretty cool for that future. So it's like really like a innovative robotic kind of help make the world better stocks. So it's like that. Any questions?
Britt, I
can't
saw that
remember
when
the
I
other
think the
stocks I have.
announcement for the little space car, and my first thought was, man, I hope they have a good team of lawyers for when one of those falls out of the sky.
Yeah.
Definitely.
So, I
Yeah,
think
I
it's
have.
for like really small.
Yeah, nothing against their engineering. It's just like Murphy lives, and so one of these days, one of them's going to have a problem.
So,
Yeah,
Brett,
but we have airplanes. Go ahead.
Same thing, yeah.
Britt,
Yeah,
I have
so if they handle it, yeah. Go ahead.
I have a couple of questions for you. Number one, how do you determine, what is your methodology for determining how much of your available investment capital is used on each of these positions that you take, your position sizing for each of your stocks out of your total capital to do it? And the second thing is, what do you use as your criteria to exit any of these stocks and get out of them?
Okay, I can only remember the second one. So my exit strategy is kind of, I like to take companies where they are to where it can be in this world. So whether I win, lose money, it doesn't matter. What matters is something called impact. So it's like impact investing is what they call it. So if the company accomplishes what it needs to and it fulfills the role in society, because the thing is, if this company doesn't, some other company will, and it's like, why are you wasting all of your money on this one if it just doesn't get to where it needs to go? Then another company has to waste all of their resources to get to that same place or higher. It's like, that's too much waste. So it's like, I try to pick the company that fills a void in society to take society to where it needs to go, and when it finally accomplishes that, they have more than enough profit, and they have just more money than they need, and they have enough to give me just a little slice of that. Then I exit out.
Okay, so what about the allocation of funds to each of these positions? Being a
Yeah.
risk manager myself, that's a really important issue as to how you decide how you allocate capital.
Well, I allocate it where it's like I give whatever a company can handle. So you don't want to give them a bunch of money and they just don't know, they cannot feasibly use all of it, so they don't know what to do, and then they have to worry about money instead of their company. So I don't give them more than they can handle. I want them to work with it, not be
Yeah,
overwhelmed by it.
but you don't have infinite funds to do this kind of thing. I assume that you have finite funds, so you must have some kind of methodology or decision making as to how much out of your total available capital you're willing to put into any one company, and that would be of interest.
Well, as I said, it's the max that a company can handle of what I give it. So
Yeah, but
their
how do you
limits are actually are smaller than what I own. So whatever I give them, I still have money left over. I just give them whatever they need. So it's never been where it's more than I have. I mean, there have been some, but eventually I do find funding somewhere. So I give them what they need, and obviously whatever they can't get from me, they'll go somewhere else. It's not, an issue.
Wait, how much do you
Brian's holding
typically
up some
invest in
book.
these companies?
Yeah, here's a very heavy tome on that subject. And what I believe Buzz is talking about is just called money management, portfolio management, maybe alternatively. And that is the art form of allocating, and again, for optimum gains, how much of what portfolio to what at what time. So yeah, it's a subject where you can do a lot of research as you try to optimize your portfolio.
I mean, it's all about priorities and opportunity cost. It's about like, am I going on vacation or am I funding this company? Am I going to have an expensive meal or am I going to fund this company? Am I going to drive somewhere or fund the company? So it's not coming out of like my money, it's just coming out of more like my life. Like, do I prioritize this company or do I matter more? Like, sometimes I matter more than the company, and
What's
sometimes the
your
company
typical
matters more
investment? A
than
couple
me.
$1,000s?
Huh?
What's your typical investment? $1,000? $100?
Or 100,000.
Right? Or $1 billion.
Oh yeah,
I
what's your
don't know. I don't
typical
want to
investment?
answer that publicly. you
Oh,
know.
okay.
But you have to realize I've only had minimum wage jobs. If I've had like 80,000 a year jobs or like millions of dollar jobs, it'd be easier, but usually my money comes out of whatever I made from another stock. So if I don't make money in a stock, then I don't put it somewhere else. And then if I make money in that stock, I have more options as to where I can put the money into.
So your primary goal with this whole thing of investing is really to support the technology and your value system about how the world should run, rather than your own portfolio management for minimal risk and maximum gain from a personal standpoint. That's what I'm hearing.
Yeah, it's all about capabilities. And the thing about capabilities is that not everything is on the stock market. And you have to realize that investing is more than just shoving money somewhere and making money off of it. It's like sometimes I had to get jobs at these companies just for them to survive because they were struggling with my money. It's like I need to make that money work to get it to where it needs to go. So I might talk to the CEO, which I've done with multiple companies, um give them ideas, and like it's kind of strange, but sometimes you actually give value to your own money, but it's just how it works. You want to find where you're creating value, so it's like um
I
I
think
do stuff like
Ackman and Carl Icahn better watch out. You're definitely an activist investor.
Yeah, and actually, I wanted to say, like, whenever anyone's worried about me not having enough money, the thing is, I will tell other people about stocks to invest in, and they will send their money out instead of me. So I never really run out of money, quote unquote. There's always money out there somewhere. Maybe I'll get a high-paying job or something. It's like it's all a matter of effort and how much money, how much risk you're willing to take, all that stuff. Uh, but and where you get it to go. But for me, I just use the excess money that I have, and if I'm not using it, I might as well create a value with it by, if there's a need out there, then I give it out there. But if there's no need, which has been sometimes, I don't put it out there, and it's not a big deal, you know.
Thank you for sharing your perspective about your approach.
You're welcome.
One question, Britt, are these, are all of these startup companies, or I mean, or a lot of them like really small startups, and are some of them slightly bigger than that?
Yeah, I actually was going to pull up a company. I mean, I like smaller companies that are sometimes on the they call it OTC, over the counter markets, which isn't an official stock market, because there's so much creativity and variety there, but it's kind of give or take with those. I don't know, but so I buy these other more legitimate stocks like that hanger stock. That this one is on an official stock market, the New York Stock Exchange, which is the most legitimate out there. This one's $100 company. This one's 20, but you get these smaller ones, $10 ones. Well, that's $10, but some of these, see, that one's a $2 stock, and that is an OTC stock. It's not like an official one. This one I think is also robotic because they do the recycling services. They have these like pipes and stuff like that. And they take the trash and everything.
You're kind
Forgot where, but there is this robotic part. But go ahead.
you're kind of acting as a mini venture capitalist, it sounds like.
Yeah.
With a particular emphasis on social good or robotics good or something like that.
Yeah, here it is, that renewable energy facility part. Like that one is like pretty automated and stuff because they take great energy from like the waste because they have a lot of recycling and everything. So it really is a mixed bag, like what you get for my selection. I just pick whatever's out there. So like people always say diversify, but I don't focus on diversifying. It just comes naturally. Like one time I only had one stock and that was like Tesla. And I just had that and that's it. And then, but now I just have all these different ones because I found through research, I mean, it's a lot of research, months, day in, day out, looking at thousands of stocks. And then
Hey,
just to
Britt?
find that one gem, you know?
Hope you don't mind me asking. I'm just curious how long have you been investing in stocks for?
I don't know. It has to be at least 9-10 years.
Wow.
But yeah, like this heavy duty, like stock looking through, that's only been a year or two.
I see.
Yeah, and there's and it wasn't enough because the thing is, and the reason why is because all these SPACs and M&As and IPOs and all these new companies with these futuristic ideas are starting to finally come out, the ones that I want to invest in. It's like that vertical farm one. It was like I just really wanted that stock, and it's like I just typed it into the news, and that day it appeared on the stock market. I was like, yes, but it was that day. So like I just bought it kind of like the next day after it popped up. So it's like that. It's like all this stuff is so brand new. Like obviously, Waste Connection's been around for what, many years. But there's all these newer stocks. Like we can see this one.
Hey, Britt,
Yeah,
can I ask you to
98.
conclude it? It's extremely interesting, but I got to ask you to conclude pretty soon because we got some other people who need some slices.
Yeah, go ahead. Wait, did you have a question or?
You have to stop sharing, Brittany.
Oh yeah, I'm so sorry. I didn't know
That's
what you were
okay.
saying.
Thank
But
you, dear.
there you go. Yay. I thought I was the last person.
No, thank
go
you very
ahead,
much,
yeah.
Britt. Les, you're next up.
Gotta unmute first. Okay, guys, what I'm doing is I worked on my little robot design, and I was trying to clean it up so I could get it ready to present. And in the process, I lost my gripper file. And then I checked my backup, and my backup drive wasn't here. And it turned out I had taken it into my wife's computer to do some configuration on her system and hadn't brought it back. And that was at the end of 2020. So none of my backups were on there. So I'm recreating my gripper. That's the long and the short of it. So here's a picture of what I have designed for a compliant claw for the gripper. I don't know if y'all can see that or not.
Yeah, you can see it pretty good. If you back off just a little bit, we'll see the whole image.
Let's see.
Exactly.
I'm not mechanically inclined. So that's basically what I drew. Now, I implemented that in SCAD. Now, see if I can share this screen. Share screen, and I think it'll let me choose which screen here. Share. Okay, you guys seeing this now?
Yep.
All right, so this is the spring element for the gripper's compliance, and it's just a 1 millimeter bar as part of the gripper. And the curve is made by differentiating two circles, and then this part is, of course, just a cube and a little cube here. Now, the reason for this lever, instead of having it attached, is when you bend a leaf spring, it has to move one way or the other. On your car, it's hung off of a couple of hinges. In this case, I've just got it fixed out here and then sprung back here, and it'll give it some compliance. And then this will be the pivot hole, and then I've got a long hole through here that I plan to put a piece of piano wire in to work against the cam that's going to drive the grippers open and closed. Now, if I go from this drawing, I have a complete image of what I'm going to do here. I haven't printed all the parts yet. Oop. There's the whole gripper as it will be. The red parts are the servos, and this servo will rotate it on the wrist part where it's connected to the arm. This servo controls the hinge. Now, if I roll this up a little bit, I'm not real good with this stuff, but anyway, there you can kind of see this is the hinge. The arm on the servo will come down here, and I will use a connecting link between here and here, and that will allow it to fold this piece so that the wrist can then be compliant in up to 90 degrees in one direction and probably about 60 degrees in the other, which is kind of similar to what we have with our hands. And then the gripper itself is going to be cam driven. I don't have the proportions quite right on the bar driving portion of it, but you can see this part here needs to come back a little further yet. So the way I'm going to do that is I'm going to move the pivot points back. Right now they're lined up for the mechanics of the gripper, and you can see the holes clear through where I plan to put the screws. And then the actual printout of the compliant gripper is like this. If I can learn to aim this camera, but you can kind of see it there. And to show you how it grips, if I push on that, you can see the spring has quite a bit of give to it. And the depth of it I limited because plastic will conform to a degree, but it eventually loses some of its elasticity, and you don't want it to break easily. So you limit how far it can deflect. And you can see here, just from me playing with them, these have already deformed a little bit. They're not parallel with each other any longer. So when they're put together, they'll be like this. And my plan is to have them about that open, which is roughly about 3 to 4 inches. And then the back part here is going to have a piece of piano wire in it that runs on a cam on let me figure out how to share the screen again. Okay, what do I do here?
You're still sharing.
Yeah. Me and Zoom are not going to get along with this, I see. That's not what I want. I want the other one. Okay. Ah, here we go. Stupid eyes. Okay. There we go. I've turned off the sharing. So the idea is then that the servos can drive the gripper and use a cam which will allow me to control the distance of rotation. So I no longer have the problem with driving the servo to its limit and burning it up or drawing too much current from it. So I think I'm getting pretty close, but me and my friend are having a little discussion with each other on sticking down to the bed again. But that's where I'm at.
Les, you get extra points for the OpenSCAD.
I'm sorry?
You get extra points for OpenSCAD.
Well, I love OpenSCAD. I'm not a good artist, as you can tell from my drawings down here. So having something I can program to get a physical object is pretty nice. So that's why I love it. Any questions?
Where is that? Is that going to go on? Is that going to go on your main robot?
Yes.
Okay. At the end effector?
It's the end effectors for the arms.
Jim, you got to collaborate with Les in order to get your arm for your robot. That'll grip your soda.
Yeah.
Actually, this could be a pretty good system. What I was thinking about is if you made a stack of 3 of these grippers, and spaced them out a little bit, you'd have something that would be compliant to an odd shape as well. So like with picking up a ball or a spool or something like that.
Have you ever gone out onto Thingiverse and just tried to look for grippers and effectors and hands and all that stuff?
Yeah, they don't have anything at all like this that I could find anyway.
No, they don't, but they do have those gearing and cam systems for causing the motion, for actually doing the actuation, I guess, off of a servo. I was, from memory, I'm just thinking of some I've seen.
That's actually the easiest part. The hard part is figuring out how to get the mechanics in the right relationship to each other. So
Les, you made a comment about not your design is set up so that you don't burn out your servos. What's the story behind that briefly again? As
when you use a servo on a gripper and it closes on something, but it hasn't yet reached the target position, the servo will continue to crank current into it until it burns up.
Yes.
Stop it.
Yeah. Okay.
So on the small servos, they don't really have any cooling. They're inside of a plastic case with no cooling. So it doesn't take more than a couple of minutes for them to burn up. And I mean really burn up. The ones I burned up actually distort the case and stuff. One of the issues with my robot at this point in time is I have an issue where when it goes down to 30% battery power, it does something weird to the communications to the pieces that control the PWM, and then the robot kind of goes spastic. I say it has an epileptic seizure. It just goes into some childish motion where it turns all the servos to various positions and runs them to lock. So that's one issue I'm having to work with too. So I've redesigned the body cavity to give me more room to put some different regulators in. And I've redesigned the hip portion so I could have a sitting position for it, which also let me increase the size of the hip portion. And I think I can stick a regulator in there for the 5 volts or 6 volts that I choose to drive the servos. And that'll help also, because once you get constant voltage, you don't run the problem of not having the correct voltage across the potentiometer that it uses for position control.
it would seem that if you had a method to detect the current level, that if there is a stoppage in the servo mechanically, that would drive your current up. If you detected that, you could shut down any instruction to keep the servo running, it would seem like.
Yeah, I've thought about that, and I have an idea for it, but at this point in time, I've got other fish to fry.
Hope they taste good.
I had the idea of a small series resistor on the return side of each servo, maybe 0.1 ohm or 0.01 ohms, and then feed that off to an amplifier and feed it into the ADC. And that would all work, except that then I have to add another circuit board and a handful of components. And then I have to reroute how the servo leads get to the servos. And I'm thinking about doing that anyway, because as Chris pointed out, if I can remove the power leads and the signal leads separate from each other, I can run the power leads as a series string down through the robot servos, and it becomes less of a bird's nest, which will make it a lot easier to control the servos and keep everything out of being pinched. But, you know, I'm about a year and a quarter maybe into this thing, and I have a robot that can stand up. That's my accomplishment so far. I have a face that can kind of move its lips, and now I have a new gripper, which I hope will be pretty neat when I get done with it.
Yeah, it seems like the bottom line to all this, you want some kind of feedback from the gripper that when the force begins to get a little too great, that it actually shuts down commands to run the servo.
Right.
That's kind of the bottom line.
You can buy servos that have that built in, but they're like $5 or $10 more a piece. And they're larger. They don't have them in the SG90 size that I could find anyway. And those servos would be too big for my robot in the first place. And the extra $10 a servo, when you're talking 40, right now I'm at 26 servos. So it'd be $260 more. I'm retired, so, you know, this is something I'm doing with my spare money out of my retirement. So, and that's why it's all 3D printed instead of me buying all the brackets and stuff that are available that you can put a similar robot together with.
Nicely done. Great idea, Les. Thanks.
Bet. If anybody wants the files, I'll be willing to give them to them once I actually get a gripper that works. I'm close, maybe another week or so. That's all I got.
Okay, thank you, Lesh. Thank you very much. Ellen, you're next up.
All right.
And if I understand, as a timer question, if I understand correctly, you've got 2 5-minute slots. Is that right?
Yeah, let's start there. It shouldn't take very long.
Okay.
All right. So the first thing I wanted to share with you guys is a lot of us do a lot of work in Arduino, which is great. It's a great ecosystem, great community. And it makes a lot of really complex tools easily accessible to beginning C and C++ programmers, which is great. One of the things that's terrible about it is the development environment, the UI, the program that you use to write the programs. There are UIs out there that are very helpful to help you to understand not only if you typed in something wrong that won't compile, but how to complete, what other compatible commands are there. And I'm sure some of you have noticed by now, I've grown rather fond of Visual Studio Code. I use it both in Linux and in Windows, and it has a large and growing ecosystem of modules and components to support all kinds of stuff. And one of the things that I ran into was a little project called Platform.io. It's a general microcontroller development framework that's built on top of Visual Studio Code. And it supports a whole bunch of microcontrollers, including things like the Arduino Uno. So for example, I've already grabbed the Atmel of the Arduino examples right here. So very similar to selecting examples in the Arduino IDE, you can select and import that project from here. And it looks, even though it looks different, it's actually very similar to the code and the way you approach the compiling that you do in Arduino. The only difference is instead of calling it an INO file, it's actually going to call it what it is, which is a CPP file. And then you have to include a header that brings in all the Arduino stuff. But here's where this gets, there's 2 things I want to show you that might get you interested in trying this out as a development environment. The first one is as you start typing in functions, the IDE will automatically suggest autocomplete based on what you've typed in. And you'll notice that the suggestions are case insensitive. So if you can't remember if pin mode is uppercase or lowercase, I can type in an uppercase P, and then I can see here that that it's actually lowercase p, uppercase M. And once you do that, it'll actually give you helpful hints about how to complete the function. So in this case, for pin mode, it wants 2 pieces of information: what pin number, and then what mode. So that's super handy when you're writing code. It'll also, by hovering over, it'll tell you what some of these default values and defines resolve to. So output happens to resolve as a 1 hex. And for this environment, the LED built-in define is pin 13. The other thing is that if you, on the Arduino side, if you're typing in something and you get it wrong, you won't know until you compile it. So you'll type in something goofy, and then you'll hit compile, and then you'll get some kind of an error message down here that relates to a line on here. What's nice about this Visual Studio Code plus Platform IO is that it does context, it validates the syntax you're typing in before you have to compile it. So here we've got a squiggly that's like, hey, just so you know, I don't know what that is, so I'm going to throw an error when I compile it. And so you can go back in and catch it. So for those of you that are a little bit frustrated by the Arduino IDE, there's other things out here. And so far, I've had a pretty good time with the Visual Studio Code plus plus the Platform IO extension. So just to put that on your radar.
Yeah, that's really great, Alan. It's in the software industry that I've been in, I've always required tools in my job that do what you're saying, IntelliSense, quote unquote IntelliSense, that shows you auto completion and all these advanced features of IDEs. But the Arduino IDE had none of that,
Yeah, and they have a new beta version that does some small portion of that. But yeah, I'll be honest, it's if you're just starting out, stick with the Arduino IDE and the community and the libraries, because you'll have a lot of support there, right? Any question you have is only a Stack Overflow Google search away. But once you start getting more into it and looking for some additional support from the IDE, then I can highly recommend this Visual Studio Code Platform IO option, because it back in, I can't believe I'm saying this out loud. Back in the old days, programmers, before we were developers, there weren't a lot of platforms.
That's so good. I'll just let you know that that's 5 minutes.
Okay.
You old timer.
That you could memorize the entire application interface and commit it to memory. Now it's not a matter of memorizing the API, it's knowing how to answer the question quickly to get the job done. So it's pretty cool. So the next thing I wanted to show you was
Alan, where is this obtainable from?
Microsoft, like a Google search, download Visual Studio Code will get you to the right place. It's open source, but it is Microsoft, and it's pretty well supported.
Actually, I use Visual Studio Code for different things like Unity, and it's a lot of fun. I think I would prefer it to Arduino.
Yeah, there's a lot of stuff out there for when you're ready to take that next step to more advanced development. And I don't want to call it throwing off the training wheels, because you can do a lot of really great stuff in Arduino, but you lose some flexibility in how it simplifies these objects, projects, and peripherals. Can everyone see my screen again? Am I sharing?
Yeah, something fuzzy.
Okay, so yeah, just a quick story about how this happened. I'm going to blame Sergey for this. I'll show you why in a second. I came across the Kickstarter project about a fuzzy robot, and on your own, look up the video for Mothman. It's cute, it's fuzzy, it's got this kawaii quality, and it piqued my interest. So I put it in the back of my head and said, oh, wouldn't it be fun to make something fuzzy one of these days? And then from one of our last meetings, I'm sure you guys remember that tiny manga doll bot, a feat of engineering with bespoke custom gearboxes. And, you know, it's just, this is a labor of love right here. And it's something that's super small that shouldn't be able to move that does. So I put that in the back of my head saying, okay, super small still moves, that could come in handy. And then Sergey made that post on Google Groups about the ESP32 Cam. And so this is why I blame him. Everything clicked. It's a dual core 240 megahertz processor, a bunch of IO, 3.3 volt tolerant. This particular version of the board has a camera interface, and there are vision, web, face detection libraries that come from the Esp32, the developer, for free. And so all this came together into this Frankenstein project to build something super small and cute that that I'm calling Kawaii. So I've got when it's actually built, the first version should be about 90 millimeters butt to nose. It'll have a camera. It should be able to face track. It's got a little tail that wags. And I decided to finally take my own advice. I had mentioned to a friend that it's better to iterate often than to spend your entire life designing something and not getting it to paper or you know, get it in your hands. So last night I rearranged some stuff with the components that I had to get something ready to play with, so I could learn more about the pan tilt, pan tilt, the free RTOS servo control. And so this is the guy I've got on my desk right now as kind of a demonstrator. He's it's got the Deadly Frankenstein wire situation. I was curious about if I could run the servos and the board off of 3.3 volts, and it turns out I can't. So I've got a 4.5 volt buck down converter, and let's see if this will run. And so I've got my version of the Hello World example right now, where I have got a free RTOS, the multi-threaded library. I've got a thread to wag the tail and a thread to move the head. And they're going through some motions just to familiarize myself with the framework. This is being done in Visual Studio Code, but not Arduino. It's actually using the libraries and the build system from Esp32, the people that create the designs for the ESP32 boards. So I'm hoping over the next couple of weeks that I'll be able to integrate the face detection with the servos to do some face tracking, do some fun stuff there, and make the tail wag, you know, faster or slower based on if it sees someone or not. And then this is supposed to go into something soft and fluffy and terribly small for like a pocket pet. So this is the rabbit hole I've fallen down most recently.
Very nice.
That is so delightful, Alan.
That's pretty cool.
So yeah, I'm hoping to have, I'll learn how to apply the fur. It's supposed to be a pocket pet with a little IMU that when you put it in your pocket, it'll look down and it'll still be able to identify faces. And there's all kinds of fun stuff that I'm doing with the vision library. Depending on what slots open up, I might be able to give them a longer talk on how all that fits together, but it's fun and everything just works. It's I haven't had to come up with much from scratch so much as grabbing and applying off the shelf libraries to get these things to work.
Boy, isn't it amazing how our technology has become so small? You can put all of these functional things in such a small space now. That is so neat.
Yeah, this is the future of dolls and toys for kids, you know, fully autonomous, aware features. Alan, you should start a company if you get this going.
Right? Be nice to turn a profit on one of these ideas, right?
Robot toy company.
Don't turn your hobby into a business, though. It's not a hobby anymore.
This could be a business that Britt could support for you and invest in.
Yeah. There you go. You got your first investor there,
yeah,
right?
Maybe I could use a
$1
little
million.
angel investor. Nice. Yeah. You know what? I could do a lot with that.
Wasn't Teddy Ruxpin in trouble for watching and sending kids information up to the cloud, though?
There's been a bunch of them. I think it started with him, and then it continued with even the Furbies were being prohibited from government installations for their possible surveillance capabilities. Yeah. This guy's a lot of the work that I do is it's direct or some cloud stuff. What's fun about this little guy is everything's being done at the edge. So the object classification, face classification, everything's happening on board.
Cool.
It would be fun to set up like a Wi-Fi web page interface, but in spite of it being a pretty fast processor with a lot of resources, that is a lot of resources being taken up for web page that could have be taken up for other stuff. But we'll see how much room I have after I get the face tracking done reliably with the face detection library.
Hey, Alan, this API comes from the company that makes this, right? But is it also used? Is there some OpenCV, as well that you use, or is it like, are these all proprietary API?
Well, they're all open source and published by Esp32, who are the makers of the modules. So if I go back to, let me share, go back to the screen really quick. So when you look at these, oh no, let's grab the back side of it. So Espressif makes these modules. So they're all-in-one modules, and they have all the requisite approvals for Bluetooth and Wi-Fi. So what's nice about them is that if you want Bluetooth, Wi-Fi, and processing, you can just buy their module, which is already approved, stick it in your board, and you're good to go. So a lot of these, there's a bunch of these boards that support them. The name of the underlying company is Espressif, and they've got a GitHub. They've done a whole bunch of highly optimized libraries for face detection, face recognition. And they even have versions of the library available for Arduino if you want to code it Arduino style. But this is the project where I've moved over to the Espressif IDE. So there's a few more steps, and some of the steps are different, but it gives me a lot finer control over how the resources of the board are allocated and used.
Right, so this is it. Yeah, it's interesting how there's, I mean, like in our project that we're working on with the OpenCV AI kit, they have their own, with that camera, the Oak D, it's a whole bunch of, it has its own stack of, facial detection and running models and all that. And also OpenCV you can use. Of course, you could probably use OpenCV as well. I mean, it's just, that's available to you as a library, right?
Yeah, typically OpenCV is used in a Linux environment. I think I've seen a couple of ports to microcontrollers, and it's the face detection algorithm that Espressif published actually is a 3-step process, and step 1 is very OpenCV-like, in that it's looking for facial features, corners of eyes, corners of noses, and then based on finding those features, it'll draw a box based on that scale, and then do a second layer of detection based on a simplified neural net to verify if that's a face or not. So it's actually, it's pretty fast for the processor that it is, and it's pretty cool. And I've
5 minutes of questions.
That's a beautiful, beautiful ringer there, bowl. But yeah, I keep forgetting this is on a microcontroller. This is different than what I've got going in, full Windows machines or well, actually the Movidius chip, Intel Movidius is the core processor in the Oak D camera, which can run inference models of TensorFlow Lite. But that's a pretty advanced processor as well, although that runs only on 5 volts too. But yeah, that's cool that you have all that capability in a microcontroller ESP platform at the edge. I like it.
At the edge. All right.
Thank you very much, Alan. The next person is a Gene. I can't pronounce the last name.
I think he had to go, or didn't he? Or
yeah, Gene left.
Are you okay?
Do it next time.
Hi guys, I gotta go.
Yeah,
Thanks, Les, for sharing your stuff.
You bet.
Thank you.
I'll post the files once I get an actual working gripper done.
All right, so this concludes the end of the formal meeting. I'm going to turn off the recorder now. Now,